room to cut.
That's not the garbage. That's my purse.
Where can
I'm
I
gonna mute
cut?
you.
Yeah, school is out.
We'll give them another minute or so.
And we should have 2 more people signing on.
Okay. In addition to Beretta.
Correct.
I was on mute. I was saying hello to everyone. How's everyone doing?
Good morning. Doing well. How are you?
Doing well. Can't complain. It's a beautiful day today.
Yeah,
It is. It's gonna be fairly warm here in Cleveland. The upper 80s, which is kind of odd, but
I know, right? We take it when we can get it.
yes.
I just heard someone. Well, I'll give them about 30 more seconds and we'll get started because we value your time as well.
Oh, no worries.
Okay, well, good morning, everyone. I'm Doris Carson Williams, Chief Executive Officer here at the African American Chamber of Commerce of Western Pennsylvania, and welcome to this hour, How to Use NASA Technology Transfer for Small and Minority-Owned Businesses. I want to also mention and salute Beretta Bay, our new president of the chamber, who is also online with us. And let me start by saying, please go on mute if you're not speaking, and you can always raise your hand or enter something in the chat room if you have questions. Let me introduce Dr. Renee Island, who earned a PhD in chemistry from Northwestern University in 2000. She spent the next 22 years for a specialty chemical company in Northeast Ohio. In April 2022, Renee joined NASA Glenn Research Center as a contract employee in the Technology Transfer Office. She became a civil servant for NASA and expanded her role in Technology Transfer Office to include promoting support for technology transfer expansion programs, also known as T2X. I like that. To support the Technology Transfer Office, Renee helps to manage the patent portfolio with a focus on the sensors and materials and coatings portfolios. She also evaluates license applications submitted by small companies, large companies, and startups. So Renee, with that, welcome, thank you, and let me turn it over to you.
All right, thank you so much. And I'm going to share my screen and let me know. Oops, let's see. Let's see, or maybe not. All right, well, as soon as I can, I'm going to share my screen. It looks like my computer is not cooperating at the moment. But
We
I'm
see
going
it
to talk.
thinking, there we go.
Oh, but that's the wrong screen. Looks like it's just being a little slow this morning. Whoops. There we go. Okay. Hopefully you all see my slides now.
Yes.
Great. Perfect. Sorry about that. I know we are moving to the new Teams. I imagine you guys are as well, since Microsoft doesn't really give you a choice, I don't think, in the matter. All right, at any rate, thanks for the introduction. I really appreciate it. And this morning I'm going to talk about how NASA can be a regional resource. And first, just do an introduction to NASA, and then a little bit about NASA Glenn Research Center specifically. And then I'll talk about interacting with NASA, both outside and inside of our technology transfer office. I'll talk about licensing intellectual property. And then just so you can see that, this process, even though it sounds maybe a little daunting, it can be successful. So we'll talk about a couple of success stories. So who is NASA? So most people, I think, when they think about NASA, they're like, oh, astronauts. But NASA is really more than just scientists, astronauts, engineers. It's also HR, it's finance, it's all different types of people working in all different types of jobs, trying to teach the next generation about the value of curiosity and exploration. So where is NASA located? So I'm actually located at the Glenn Research Center in Cleveland, Ohio. And we have sort of a sister site. It's called the Neil Armstrong Test Facility. It's over in Sandusky, about an hour and a half, 2 hours from here. But you can see that we have 10 different centers that are either research centers or spaceflight centers. And they're pretty much all along the coasts here. We are sort of missing sort of in the middle of the United States, but we're certainly trying to get our outreach to sort of, reach all of the different states here in the United States so they can understand also what we have to offer as a resource. So what does NASA do? Well, we provide, we prove and mature technologies developed for space flight and help to reduce risk for exploration of Mars and beyond. We've got a space operations area, we've got exploration systems development, we've got a science program, and an aeronautics program. And so each of these 5 areas is sort of how the overall NASA looks at what we do and sort of defining the space for each of these different topics. So our mission is really to drive research, technology, and systems to advance aviation, expand human presence across the solar system, enable exploration of the universe, and improve life on Earth. So our strategic goals there are written on the other side of this slide. And really, while our research is focused on both aeronautics and space, we also aim to get the technologies that we develop into the hands of people here in the United States to improve the economy. And I'm going to talk more about that as we go on. So a little bit more about NASA Glenn itself. So Glenn, pictured here on the left, is actually a little tiny city, much to my surprise. You can't really see, it's right next to the Cleveland Hopkins Airport, and you can't really see a whole lot of it from the actual road. And so I think it's a very well kept secret. The first day I drove through the gates, I was like, oh, wow, there's a little city back here. And there really is. So it's around 300 acres of land, and around 3,000 employees, with half of those being civil servants and half of them being contractors. And then our Neil Armstrong test facility is actually much larger, but has fewer people at it. But there, it's a quite large test facility. So our core competencies, a little bit again about specifically about Glenn. We do quite a bit of research in the areas of aircraft propulsion, in-space propulsion and cryogenics. So it's a little bit different when you're trying to get the energy to move from place to place out between, if you wanted to go from the moon, for example, to Mars, certainly a different type of energy needs than just, than say launching out of launching from Earth. We also have a focus in power energy storage and conversion, materials and structures for extreme environments. So a lot of the work to go into space, whether that be the moon or Mars or Venus or any other site in such a remote location, really requires typically some very new and different materials because of the extreme conditions, whether that be extreme cold or extreme hot temperatures, or potentially extremely acidic environments like on Venus. And so materials is a big part of what we do. We've got a brand new communications building on site, and they're basically kind of brought all the different folks working in our communications areas together in one place on campus. So communications is also something that we work on. And then finally, physical sciences and biomedical technology. So this is just a little bit more information about our research and engineering labs. And again, with highlighting sort of our materials, we work on acoustics, right? So one of the big focuses is on making hypersonic vehicle travel possible over land, for example. So acoustics is very much a big part of that. We want to make the sonic boom more of a sonic thud, so that you can have supersonic travel over land instead of just over the oceans. Again, this is actually a picture of that new communications building that just was opened up recently, about a month or so ago. And again, aero propulsion is a big part of what we do, as well as power and energy storage, and as I mentioned, in-space propulsion. So at NASA Glenn, we do have some very unique test facilities. So that vacuum chamber that's up there, that's actually at our Armstrong test facility in Sandusky. And it may look familiar for any Avengers fans out there. It's actually where they filmed like the opening scene in one of the Avengers movies. Fun fact. So we do testing as well on mechanical vibration, as I mentioned, acoustics. We've got an extreme environment rig, and that was actually developed to go to expose materials to the atmosphere of Venus. So that's actually quite high temperature, quite high pressure, and quite acidic. So that's an impressive thing to see. We've got zero gravity research, so that's kind of cool. It's a drop tower. It's actually, they dug a very large hole and they can fill a capsule essentially with equipment that essentially they drop the capsule from the top all the way through to the bottom. There's like styrofoam beads there. To allow what's inside the capsule to experience a few seconds of weightlessness and determine whether or not it's still functional in an environment that's much different, more closer to what they would find on the moon. And then our slope lab, which is really like a big sandbox. It's kind of cool. It's honestly it looks like a big sandbox, and it can be sort of tilted at an angle so that you can simulate the topography, if you will, of say the moon. which is certainly not necessarily flat all over, or Mars, which is not necessarily flat all over. And so if we're going to send rovers out there, we need to make sure that those rovers can traverse the different types of surfaces. So those are some of our unique test facilities as well. Those are in the space area. In the aeronautics area, we've got a couple of wind tunnels. Again, we've got our aeroacoustic propulsion lab. We've got an icing research tunnel. And propulsion systems lab, engine component facilities, and then we've got this electrified aircraft technology site as well. So I want to talk a little bit about interacting with NASA and opportunities to interact with NASA. And I'll start a little bit discussing what these opportunities look like outside the Office of Technology Integration and Partnerships, but then we'll go into what it looks like inside the Office of Technology Integration and Partnerships. So certainly one of the most obvious ways to work with NASA would to be, in employment, right? So we have internships. I'm not going to go into any of this in a lot of detail, but there's links there for interns. And then any jobs that are posted, go to usajobs.gov. And then we've got our procurement as well. So we do have a function for the Office of Small Business Programs, and that helps small businesses to become qualified to be a supplier to NASA. And then briefly, there's some information here about solicitations and challenges. So just another moment here to talk about our Office of Small Business Programs. And this office, like I said, their goal of this office is really to help a small business to know and understand what they need to do to become approved as a supplier. And if you go through that process, really, I think you would start it sort of with a particular NASA site or center. But when you go through the process, you become an approved supplier for any NASA site. There's like I said, a whole business here, or whole office dedicated to helping small businesses to learn what the requirements are and really how to achieve the status of an approved supplier. And so there's more information at the links on here, and I'll send the slides over after the presentation's done so that you have the slides with all the links. We've also got challenges that come out from each of our different directorates, and this is a chance for anyone really from the public to sort of read about what NASA is wondering about or curious about. There is prize money awarded for solutions to these different challenges. Unfortunately, all of this information is not sort of just at your fingertips per se, but this slide is sort of an attempt to put that information sort of all in one place if possible. And I'm sure there's things that are missing from this, but again, this is kind of because the challenges may come, or the information may come from different directories or different parts of NASA. It's not as centralized as one might hope or like. But if you see a topic here, and again, I'll send these slides over, you can either click on these or really just probably type in the same title here, and it will take you to a variety of links with more information about our resources and opportunities. So interacting with NASA inside the Office of Technology Integration and Partnerships. So we've got, and within our division, so of NASA, we're actually we call ourselves code team. Everybody has a code, but within the Office of Technology Integration and Partnerships, we've got sort of offices that aid with idea incubation, as well as those that are more focused on idea commercialization. So I'm actually personally most focused on our licensing, and so I'll talk about that more in a few slides, but I don't want to sort of skip over the part about idea incubation, so I'm going to talk about that a little bit first. So we'll talk about the SBIR program, and this is actually specifically designed for small businesses. And we do use alphabet soup, and I think I do try to, there's a small SBIR stands for Small Business Innovation Research, and STTR stands for Small Business Technology Transfer. We have similar kind of programs for academia. They're aimed at academia, and I know this is more of an industry-focused sort of group, so I won't spend a ton of time there, but I just wanted to let you know that we do also have programs aimed at universities. And if you happen to know or be friends with professors at universities around the area, absolutely feel free to share what you learned today with them, because we certainly engage with universities as well. And so let me start off with a little more on their SBIRs. So SBIR is a way in which NASA helps to fund small businesses to do research, basically to help solve real problems that NASA, is trying to investigate. So the innovators at NASA will put out a solicitation and say, here's the problem essentially that we're trying to solve. And, we're looking for your work proposals on how you would go about solving this. And that's where phase 1 awards are solicited. And that's just basically for idea generation. And they have typically a 6-month time limit. And it's really for sort of proving out that your idea is valid and has merit. And if it goes well and is successful, then you can apply for a phase 2 award to further develop the concept or idea that you are working on. And then a phase 3 would be for infusion or commercialization. So these are opportunities, like I said, just to really work directly with innovators at NASA, or maybe not work directly with those folks, but work on a problem that they are particularly concerned about and looking for, solve solutions out there. So this is certainly a way for small businesses technical-based businesses to sort of work with NASA. The STRG program, the Space Technology Research Grants program, is aimed at universities, as I mentioned earlier. And there are a whole variety of awards sort of listed here. The first one I think is the only one for sort of graduate students. The rest are really for faculty members. But again, these are available for folks at universities, again, to sort of work with or work on a problem associated with, some of NASA's research concerns, and this is just yet another opportunity. So my area that I work in is in the area of patenting and patent licensing. And so this is what I get most excited about. A patent really is an exclusive right for an invention. And in order to obtain a patent, the invention or the idea has to be both novel and inventive, and it has to have a specific purpose. So, if you just sort of optimize something and make something that's already out there better, that can be a little more challenging to obtain a granted patent from the Patent and Trademark Office. Those are really the main qualifications that are considered by the Patent and Trademark Office when they're reviewing your idea. A patent gives an inventor exclusive rights to their invention. So basically others can't make or sell or do what you're doing really without your permission. So if you obtain a patent, essentially you are, like I said, excluding others and allowing essentially, yourself to sort of work in that space. And if you find that others are working in that same space, you can basically take legal action against them and the first thing you would do is sort of send a letter to cease and desist to those other people saying, hey, I have this patented and this is not a space you can work in. But not all companies, when they license or when they patent, are actually intending to license their technologies. Some companies are patenting to prevent their competitors from working in their space. NASA, on the other hand, is patenting with the aim of licensing their technologies. And licensing a patent really is just a contract, basically, between NASA and the licensee. So, which is got to be a legal entity. So we don't license to individuals. We license to a legal entity, and that contract then basically gives the licensee the rights to make, sell, and use the patented invention. So as a technology manager, in our working with our patent portfolio, it's sort of the role is twofold. So one of the main roles and one of the main jobs that I do is evaluate the research that NASA is inventing. And we make a determination in our office about whether or not we think that the idea is something that could be used commercially or developed into a terrestrial product, basically. So we don't patent every invention that the NASA researchers come up with. That's not our goal. Our goal is actually to patent the things that we think could have a commercial and a terrestrial use. So, we look inward into NASA to help manage the technology and the patent portfolio that comes through, but then we also look outward for companies that would be interested in licensing those technologies. You can see a few pictures of this. This picture right here is a tire that actually just it can deform basically as it's going over rocks or whatever, and it springs back to its shape as soon as it's moved away from that. So that's just one example of some of the technologies that have been patented by NASA. And you might be wondering where does this come from, or why is this, when did this come about? Technology transfer really it's an obligation that all federal labs have. It's not just NASA. Every federal lab has an obligation to promote their inventions for commercial purposes. And so really the legislation that created technology transfer, the main legislation started off back in 1980. And since then, there's been a variety of additional acts, agency acts, basically, that have further defined what technology transfer is. And so this really is a congressionally mandated thing for us to find, to market our technologies and try to find companies that would be interested in licensing them. Right? And the idea being that the tax dollars that we all pay, right, is what pays for the research at these federal institutions. And so, we want to be able to basically utilize that research in any possible way to sort of give back to the community, either by stimulating job creation or by helping businesses perhaps expand into some adjacent space or get into a new space that they weren't into before. And so it's actually a mandated activity that we do, and all federal labs are required to have a technology transfer program. It's not, like I said, it's not simply just NASA. So I just grabbed this this pie chart from some recent statistics. This is actually for all of NASA. It's not just NASA Glenn Research Center's technologies that are listed here, but you can see sort of where these technologies, what they're about, if you will, or what their end uses are for. And you can see, as I mentioned, one of Glenn's core competencies is in materials and coatings. And that's kind of a commonality. A lot of our offices, a lot of our research offices do have a focus on that because, again, in order to do and go to all these new places, we generally need to develop new materials that can withstand the atmospheres there or the conditions there. But you can see there are other groups that our patents are sort of geared towards. So we've got propulsion here, we've got robotics, sensors. And so there actually is around 1,500 patents agency-wide. If you actually added the numbers on this slide up together, it's around 1,000. And the reason why the number of patents doesn't really match with the number of topics here is some of our topics, if you will, kind of involve multiple patents. So some of these are actually cover, sort of a group of patents that are all related to each other. So if you license a technology, you may actually be licensing more than one patent because we may have patented, you may have additional patents that describe the same or something similar. And so we've lumped them together, if you will, so that folks can take advantage of all the different patents in that particular area. So where do you find this information? Well, you go to technology.nasa.gov/patents, and what you'll see is a screen that has these 15 categories, and the categories represent sort of the end use of the technology. So again, we go back to that materials and coatings. We've got manufacturing, sensors, optics, propulsion, robotics. So the list of categories is all here. If you were to click on one of these categories, what you'll see is opening up is sort of some small pictures that describe the technologies, and then a very short description with a button to read more. And so you can sort of browse through this, however you enjoy to browse through it. You can actually filter this so that you're either looking at technologies from a single location, or if you go into, you can filter it so that you're looking, obviously you can click on one of these categories so you don't, again, have the whole portfolio, you just have technologies aimed at that particular end use. And so there are ways, you can also search it by keyword, but it's not the best of keyword searches, unfortunately. So really, I think, it's better to either focus on an end use and kind of go from there and kind of peruse through it as as you're able to. If you do click on the read more, what this takes you to is what we call our top sheets. And these basically are just descriptions of our technologies. And it includes sort of information about what the problem was, what the invention is, what the benefits, what we think the benefits are, and where we think the invention can be applied. So which types of end uses. And so these features are part of each TOPS, and they all structurally look like the same, so that they have a description of the technology, along with some of the benefits and some of the applications that we think could be useful. In the corner, when you do open up one of these TOPS documents, you'll notice two buttons, one that says ask a question and one that says apply to license. So if you would like to ask a question, absolutely hit the ask a question button. It'll open up an email message that you can send. We have a concierge who actually takes a look at all the questions as they come in and kind of filters them to the right center, so that the right person is answering the questions that come through. And then if you hit the button on apply to license, this is actually the way you would get started if you were interested in licensing the technology. It's really as easy as clicking that button and going from there. So if you do click that button, what happens? You would fill in an online form, and that form would contain some of the basics, obviously, like your name, the name of your company, the location. So it's important to note that a licensing agreement is between two legal entities. So it would be between the center where the technology was developed and then the company that you formed. So if you have an invention, but you're not already incorporated as a limited liability company, you want to form a limited liability company before you apply for a license. They also are going to ask some questions, some very basic questions about what do you want to do with the patented technology? So what do you see this becoming? There's a note here, be sure to submit the license once the application is complete. And that may sound silly, but we can kind of, from where we sit on our side of the fence, we can see when a license is initiated, but when you initiate a license, it's not the same as actually submitting it. So you can sort of work on it, if you will, and it gets saved in a space. And for us, it's in a bin called initiated. And so we won't really typically follow up with a license that's just been initiated. But when you hit submit, then we'll follow up with you. So be sure to hit the submit button after you're done filling out the form. And the license application will then be reviewed by the Technology Transfer Office at the location where that invention was discovered. And then we'll assign a licensing type. And I'll tell you about the types of licenses in the next slide. But generally speaking, then you would be contacted by the Technology Transfer Office for a meeting. So you should expect to hear back probably within, a week or so. We do try to be, to act on those as quickly as we can. Just that first contact once you submit the license application. So we try to sort of be, as responsive as we can to set up a meeting and just to further discuss your interest in the invention. So it's a relatively informal meeting with someone like myself, and really what we just want to hear is a little bit about your company, and again, what do you intend to do with the license, the technology itself. It's very it's very informal. And after that meeting is over, there will be, if you're still interested, so, a lot of folks sometimes we'll have that meeting, and sort of as they learn about the program and as they learn about what they get and what they don't get with the license, sometimes folks change their mind. People will ask a lot about samples. Do you have a sample of this, or do you have a prototype of that? And unfortunately, the answer typically to those questions is no. We don't often have samples or prototypes to offer because NASA's not in the business of making and selling things to the public or to anyone. So we don't often have samples of materials. We don't often have prototypes. There are cases where we may. But more often than not, we don't have a sample to offer, and we don't have a prototype to offer. We do typically try to offer the time of the inventor. So we typically we can set up a meeting with the inventor so that you can ask any technical questions that you might have. But really, it's kind of up to the company to, with license, to basically go in. They can, with the initial license that I'll talk about in a minute, you can either make the material yourself, you can have it made, or make a prototype or have it made for you, and you can test it. And you have to either be able to do that on your own or find somebody who can do it for you. But it's not typically something NASA can do for you. Again, there may be an exception, and we would just certainly discuss that during the meeting. But that's something that not everybody sort of has a good understanding of. So sometimes when they hear that and they're like, yeah, maybe this isn't for us, and that's fine. But we try to kind of give you an idea of what to expect. And once that meeting is over, the recommendation will be made within the NASA Center to grant a license. The licensee will sign the agreement, and then the NASA Center Management signs the agreement. So we actually try to make this a relatively easy process because we're not trying to discourage people. We really like people to, take out a license if they have an idea for how to use a technology. We don't want to discourage folks, so we try to make it relatively simple and straightforward. I'm going to talk a little bit about the different types of licenses that are available. We usually start folks off on what we call an evaluation license. And that's to just test drive the viability of what you want to do, right? So if you think that you know we have this material that we've invented and you think it'd be great for use in some application or whatever, the evaluation license will give you the opportunity to, like I said, either make the material or have it made for you, and then test it and see, does it work or will it do what you want it to do for, you know, the end use that you have in mind. And the evaluation license, sometimes called a research license, it usually has a term of a year, and there is a fee involved that we often waive for entrepreneurs. But the fee is $2,500. It's not meant to, again, we're not trying to, you know, make this too difficult or anything like that. But we do want to make sure that the people who are taking a license out actually do have an intention to evaluate the technology. And so, you know, we do institute that fee. Certainly there can be some negotiation there. Again, for small businesses, we typically will, or for not for small business, for entrepreneurs, we'll often waive that fee. If your company actually is developing or wants to develop a product that's really something that'll be sold back to the government, so say the military or any branch of the government, frankly, then we would issue a government use license, and there is no fee associated with government use license, but it is usually associated with, say, a contract from a government agency, right? So if you're a small business and you get maybe an SBIR grant from, say, the Department of Energy, you know, then, and you see some NASA technology and you think, hey, we could solve this problem that the DOE has this SBIR about with this NASA technology, then you would get a government use license for that technology. And for the length of the contract that you have with the DOE to do investigations, that's how long your government use license would last. And then finally, we have a commercial license. So this is the type of license we would issue if you want to make or sell products based on the technology. So with the evaluation license, you can, like I said, you can make, you can have made, and you can test, but you can't sell. If you want to sell something, you have to convert to a commercial license, and the terms of the commercial license are negotiated with each individual company, because it could be that you want to sell something that's crazy expensive and you're only going to sell, you know, a couple 100,000 of them. And so we might talk about minimum fees, we might talk about royalty fees, but it could be totally different. Maybe you're going to sell, you know, millions of something that, you know, has a lower cost associated with it. And so because of the fact that the nature of the product and the cost of the product can be different and the expected volumes can be different, we will negotiate the terms of the commercial license separately with, you know, the different companies that are interested in those licenses. So NASA not only has patents, but also software that can be provided free to the public. Software is actually free with a registration, so you do have to provide information about who you are. And, you know, what they're typically looking for is, are you a US citizen, and can they verify that? But other than that, really, they will authorize typically, you know, whoever applies for the software, you know, the use of the software. And so the software is set up very similar to our patent portfolio. And so it's divided into the end uses. And so you can see what those end uses are here. And so it's similar. You would click on one of these topics and kind of look to see what's available from a software perspective. So both patents and software things that could be you know, obtained or get access to using our technology transfer office. One final way, I guess, or one other way to interact with NASA is what's called the Space Act Agreement. So a lot of the other government industries will call this a Cooperative Research and Development Agreement, or a CRADA. but NASA calls it a Space Act Agreement. And this really would be more, some companies that seek Space Act agreements have a product that, it may be something that's sort of space related, but maybe not completely space related. I actually help to support our sensors technology, and we've got a Space Act. We've actually got 2 Space Act agreements that were recently signed with companies who wanted NASA to make the patented sensor technology for them. And so they have both a research and evaluation license and a Space Act agreement where they have basically, between that company and NASA, they've decided on what the statement of work would be. And they've agreed on, reimbursing NASA for the time that the researchers, for the time that they spent in the materials to make those sensors. And then we're going to deliver those sensors to these companies so they can do and test and use and then decide if it fits what their need is. So that happens. Sometimes these Space Act agreements are also more intimately tied with an actual mission goal. And in that case, NASA will pay its costs, and then the other company involved in the agreement will pay its costs. And the agreement will be set up appropriately. So that's another route for working with NASA. A little bit about our Technology Transfer Expansion Program, or T2X. And that's sort of another thing that I've been involved in, which is really to increase awareness of NASA as a resource. And so, I present webinars to groups like yourselves, and or I'll go to an expo or something, or talk about NASA and the patents portfolio, and the fact that we have these patents available for licensing. So we try to understand what the regional resources are. So if there are accelerators, for example, that we can introduce folks to within their ecosystem, or angel investors maybe in their area, we do try to help entrepreneurs. So the T2X program is actually it's licensing, but it's really with a focus on an entrepreneur. And it's also about educating folks, right? So we try to do a lot of more outreach to either universities or to companies or to groups like yourselves, to really kind of explain what we do and what we have available, and the resource that we can be, so that people understand it. So as I just mentioned, the emphasis is on entrepreneurs for our T2X program. We also do have a program that we call T2U, and that's Technology Transfer University. And that's actually a unique program where we try to go into universities like entrepreneur program typically, and we'll basically explain to the students how they can go into our portfolio, find a technology that they have an interest in, and then we ask the students to come up with an idea for a product based on a patented technology. And then their job typically, over the course of the semester or the year-long class or whatever it is really to learn, about sort of startup principles, customer discovery, and just really all the things that you would need to consider, the supply chain, the logistics, all that stuff. The entrepreneur class would address, but within the context of, an invention that stemmed from NASA's technologies. And so again, if you've got kids who are, going to college anytime near future, or this is something you think would be cool for a community college nearby, we'd love to hear from folks, and I'd be happy to speak in more detail about the program and how it can be utilized at colleges and universities nearby. So really, what I wanted to talk about was, what we have basically what we have in the way of support, right? We have research and development folks and subject matter experts. We have test facilities. Those test facilities actually can be, you can utilize those test facilities if you are a tech-based company and you want to test your invention. You just have to contact NASA. It has to be for a test that's really unique to NASA. If you can run that kind of testing somewhere else at another lab, we're not trying to compete with another lab. So if it's possible to use, a lab that's already out there, then we would certainly try to refer you there. But if it's something unique to NASA, we would, you can potentially work out a way to be on the testing schedule and get your materials tested. And then certainly, as I just mentioned, we have our patent portfolio, our intellectual property. And, at times we, if possible, we would offer the assistance of our subject matter experts. So this slide just shows some examples, right? So it may still kind of sound like a very intimidating thing to do, but it's not an easy thing to do. Let me say that for sure, right? And becoming an entrepreneur is certainly not an easy thing to do. But folks do. We've got examples here. These are the logos of the companies, and really what it shows here in the rest of these little pipes, I guess, if you will, is sort of what the what the programs were that these folks participated in. And potentially they went through a FedTech program where, again, they learned about Lean Startup, or I think there's this is an example of someone who went through the Professional Sports Association training camp. And so again, these are ways and programs that were utilized by these companies. And then this one used a manufacturing partner that we have locally called Magnet to help build the prototype. And so these are sort of like the resources that were available to the company sort of along their journey. So it's not just sort of, it's not maybe just all coming from NASA, but from other, but help can come from other government organizations like these manufacturing partners, expansion partners. And here's some examples of things, right? So one of my favorite examples is memory foam. People may not realize that memory foam was actually developed in the 60s for the Apollo landings, basically to cushion things on re-entry into the water. And so to absorb the blow, if you will, from that impact, memory foam was developed. And, since the 60s, right, it's found its way into like airplane seats. It found its way into motorcycle seats. Then it found its way into mattresses and pillows. So memory foam has been around for a long time, and it wasn't developed for any of those uses I just mentioned, but folks over time have said, hey, this is a cool material. I think we should put it in a mattress. And they did, and have, successful businesses based on that. So other things listed here, the one of the other things I like to point out is the invisible braces that folks wear these days. So that was actually a polymer that was developed by NASA. And, somebody said, oh, it's a clear looking polymer and it's moldable. Maybe we could use this to fix people's teeth. And there you go, invincible braces. So that's really what technology transfer is about, right? It's taking something that was designed for a different purpose, right? And just sort of saying, well, what else could we do with this, and what would people be interested in, right? The camera on everyone's cell phone that they walk around with is another example, right? NASA's research goals are often to make things lighter and make them smaller. And they made a camera super light and super small, and somebody said, hey, we're carrying phones in our pockets, the old flip phones. How come we don't put a camera in them? And, now we all carry around cell phones with a camera in it. So, again, just some different examples that you may or may not be aware of technologies that started off as technologies developed by NASA and became things that you used in your everyday life. we actually have publications that highlight these success stories. It's called spin-offs. And they're published, this publications, it's a magazine that's published annually. So you can take a look through that and be inspired by the different inventions that have gone on to become commercial successes. Just real brief, this is an example of a company that's called Ozark. They are Ozark Integrated Circuits, and they have taken NASA Glenn's integrated circuit technology, and they are working at commercialization of this particular technology. This is Aaron Wallace. He's the founder of Wondrous, and they are working with our multi-stage filtration system. He took advantage of the manufacturing expansion partner there, Magnet, to get a prototype made. And so, you know, these are real folks who have gone through the process and are still sort of, you know, honing their invention and working on it towards commercialization. So that's all I have. If there are questions, I'd be happy to entertain them. Although
Renee, you are a wealth of information.
Why, thank you.
I get the impression that you could talk to us all afternoon about NASA because you enjoy your work.
I do. Thank you very much. I'm glad that you get that impression. So I appreciate that.
Does anyone have any questions?
No, I don't think there's any questions, but I will say that I'm still blown away by the technology and the practical use that they simplified the technology down to use like memory foam.
Yeah.
It's amazing. It's impressive.
It's fascinating, you know, to sort of see kind of what people will think of, you know, and what they come up with. And yeah, I mean, memory foam's a good one because it's really been like reutilized and then reused again for something else. And like, I think it's in airline seats as well, right? When you get up from your airline seat, there's usually not like a big impression of your butt in this sitting in there.
Yeah.
Kind of it goes back to shape.
I think I have a couple of pair of golf shoes that have the memory foam in them as well because they're so comfortable.
Very cool.
I would just say too that I really appreciate you taking the time. I think that this is still intimidating for some of the small businesses that we're dealing with. I think they think it's bigger than what it is, and I don't know if it registers with them or not.
And I totally agree. I honestly, it's you know, when we do go out in a public forum, frankly, we do have some trouble like sort of fielding folks who want to listen to the message because I do think they're like, ooh, NASA, what does that have to do with me? But really, we just want people, you know, to sort of listen to the message and go, oh, I didn't know that, you know?
Yeah.
Well, that's fascinating. And, you know, and just really, you know, because, and really the more people we can reach with that message, the better, because you just never know when you're going to find that person who like looks at the technology and goes, oh, well, I really want to solve this problem with that. And, you know, right. And then they go out and, you know, and make a company. So, yeah. So anytime we can try to, you know, get more people to sort of hear the message, you know, the better, really.
They'll share it. Yeah.
Exactly.
Yeah.
And I think, you know, you guys were recording it, so I appreciate that you were able to sort of, you know, hopefully put a link on your website so that people who maybe couldn't make it could at least view it, you know. But yeah, it is kind of a message, I think, that folks, you know, are not maybe, you know, they don't really think it's for them. But again, what we're trying to say is it could be for you. It could be for anyone, you know, right? Again, I mean, like the person who probably developed, you know, the braces was probably a dentist or, you know what I mean? Like they weren't like you know, they probably weren't like a geeky scientist. I mean, I'm a geeky scientist, but they probably weren't. They probably said, oh, you know, this would be cool to, you know, like instead of putting metal in people's mouths, we could put this clear polymer and then people won't necessarily know that you're, you know. That's wonderful. Right. So it's really just, you know, right. It's really just getting people to sort of think a little differently about, you know, what they're seeing and viewing and, you know, hopefully spark a, you know, a thought that like, well, we could do that. We could make this, you know.
Yeah.
Well, we will definitely we'll share this, and I'll definitely continue to talk to some of our members in technology and engineering space too, because I think that they're missing the mark in how they comprehend this and understand it.
Well, I really appreciate that. So, like I said, we're definitely open to speaking to folks who have interest, and we don't try to make it an overwhelming process or a difficult process. We really do want people to, be able to run with something and it's
And be a
it's
part
a-
of it.
yeah,
Yeah.
it's a neat, it's a very cool goal. So that's, it's what I like about it. Plus I am a geeky nerd and I like to learn new stuff. So.
Well, we thank you for presenting with us today.
Yes, thanks for
And
your
just
time.
so as a reminder to everyone, a survey will be sent out and we'll respond, Renee, and give you the results of how this was received.
Great.
Also want to remind everyone that June 14th is our Power Breakfast meeting with Dr. Quentin Bullock, the president of Community College of Allegheny County. And obviously, don't forget our golf clinic, June 26th. It's fun. You got to come and do it with us. Thank you all for your time and attention. And this concludes our NASA How to Use Technology Transfer for Small and Minority Owned Businesses. Thank you for attending. Bye-bye.
Thank you.
Thank you.